Welcome. My name is Dr. Billy Bullock. I'm a certified industrial hygienist and AIHA fellow. I have been a member of the AIHA Exposure Assessments Strategy Committee for over 15 years. One of the Exposure Assessment Strategies Committee's missions is to develop tools that will assist practicing industrial hygienists with workplace exposure assessments and to help them interpret the data. The AIHA Stats Spreadsheet is one of those tools. It was originally developed by Dr. John Mulhausen with 3M. That is the current macro-free version. The new version was updated by Daniel Drolet with the assistance of several graduate students at McGill University in Quebec. They included multiple languages and a nice Visual Basic skin and updated graphics. During this demo, I will be showing you the macro-free version. However, all aspects of data entry and interpretation are the same with both versions. If your computer will allow you to run macros, you might want to try the newer version. The first thing you will need to do is go to the AIHA webpage and click on the tab titled Get Involved. Next, you will want to select the tab that says Volunteer Groups. When the AIHA Volunteer Groups landing page opens, scroll down to locate Exposure Assessments Strategy Committee. When the Exposure Assessment Strategies Committee landing page opens, scroll down to locate the macro version, new AIH Stats spreadsheet, or the macro-free version of the AIH Stats spreadsheet. When you click on the one of your choice, you will have to have allowed pop-ups, and you will see a dialog box open asking you if you want to download or open the file. You can select Open, and then you will save it to your desktop or hard drive for future use. Note, there are some instructions for helping you with computer security settings if you choose the new AIH spreadsheet version so the macros run properly. If you use the macro-free version, you will not need these additional instructions. Now you should have an Excel sheet open on your computer. Note, it is pre-populated with dummy data because each field has formulas in it. Do not delete the data, as that will cause an error message. In the next few slides, I will walk you through populating the spreadsheet with the data from your current school project. As an example, I will show you how to enter 15 data points from a fictitious data set from a FEMA study of workers decommissioning trailers used to house victims from Hurricane Katrina. When you complete your class project, you must enter the actual data from your study. The first thing that needs to be done is to enter the occupational exposure limit, OEL, of your choice. This would be specific for the chemical you are running the analysis on. For example, asbestos, benzene, carbon monoxide, phenol, total dust, etc. Remember, the example I am using is for formaldehyde. Because my data represents 8-hour worker exposure to formaldehyde, I am choosing the OSHA permissible exposure limit, PEL, of 0.75 parts per million. I could have selected the NIOSH recommended exposure limit, REL, of 0.016 parts per million. As a side note, you should discuss what OEL you choose and the rationale for doing so within the discussion section of your written report. So as you can see, I've typed over the pre-populated entry with the PEL for formaldehyde of 0.75. Now we are ready to enter the results for the 15 samples. You can do this by clicking on each box and entering the data. When you place your cursor on the row and column 1, row 11, which is the first line of entry, you can type in the new value without deleting the previous one. Repeat this for all 15 measurements or data points. If you do not have 15 data points, you can delete the remaining pre-populated values after you have entered the data points for your study. Remember, do not try to delete all the pre-populated data first, as this usually results in an error message. Also, if you click on any of the other columns and rows, you will get an error message that you do not have permission to perform that function. This is because there are formulas that are locked to prevent someone from corrupting the spreadsheet calculations. Now that you have all the data entered, the calculations run automatically as you're adding the results. You might be overwhelmed by all the information. However, there's no need to be so. There are only a few key items that you should use for this research project. First, look at the descriptive statistics. This provides you with characteristics of the data set. You can validate the total number of samples and match what you've entered. Next, look at the minimum and maximum values, which will tell you about the spread of your data. E.g., do you have a wide range between the min and max sample results? Then look at the mean and the median. This will provide you with information on the central tendency of your data set. That is where the largest percent of your data falls. The last item under descriptive statistics to review is the standard deviation. The standard deviation will tell you if your data points are highly variable for a large standard deviation, or the data is tight with low variability for a number that is very small. The last item you should use is under log normal parametric statistics. Environmental and AIHA data tend to be log normally distributed. The 95th percentile point estimate provides you with information related to the distribution of the curve. The number you see is the point at which 5% of the data is higher or exceeds that level. or you can state it as 95% of the data is below that point. Your lecture notes discuss how AIHA uses the 95th percentile point estimate to recommend controls. These are called the AIHA exposure control categories. Again, a discussion on this is provided in your unit or module notes or study guide. There is one other feature of the spreadsheet that you might find useful. It is the idealized log normal distribution chart. My fictitious data set came out looking like a normal distribution, or the classic bell curve. However, most of the time you will see a skewed curve. The blue line on the curve represents the 95th percentile point estimate. This helps you visualize where the majority of your sample results fall in relationship to the OEL. Since our OEL was 0.75 parts per million, that value is far to the right of the blue line and is not represented on this graph due to the scale of the graph. However, your data set and resulting graph may be much more interesting. Good luck and enjoy this assignment. This is real-life industrial hygiene. If you still have questions, please contact your professor for additional assistance.